Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we are going to look at real world applications of data science, and here this is about automotive, and we are going to look at how we can detect bolts in a car. So as you can see, bolts have been used as fasteners since many years, and especially if we are look, there are different types of bolts. You have different threads on it, different diameters, different lengths, and they can be used here as shown in this picture. They can be used to fix the seat of the car on the chassis, or it can be used in case of putting the shock ups of the car or tires. So there are several cases where the bolts can be used along with the nuts. And the reason why it would be useful to be able to identify these bolts and nuts is in use cases such as a robotic assembly line, where a robot could go ahead and find there is a bolt there, and it could go ahead and then turn that particular bolt to the required torque. And that could be one application. Another application could be, let's say we have an auto store and the store has different types of bolts for sale, and a customer walks in with a specific type of bolt that they need. Now the person in the store has to decide where the bolt is located and what type of bolt that is, and if they have it in stock. So instead of a manual task, if there is a AI behind this could be automated. So the person in the store could take picture of the bolt from the customer, and the app could analyze the picture and tell exactly which aisle that particular type of bolt is located. So those are some of the use cases of this particular method, where we are just trying to identify bolts. So for this particular project, I've chosen to take pictures of nuts and bolts from the car engine bay mostly. And here are three pictures. The first picture on the left hand side is the engine bay compartment, and then the right picture on the right hand side is the below the car body on the rear wheel, and then this is the picture of the bolt near a seat. So let's go outside and look at the car engine. So here we are in the looking at the car, and this is as you can see, there are a couple of bolts on the main frame. Then here we have the bolts, three bolts on the pulley, and then one bolt right there on the main frame. And then these are the prominent engine bolts that we can see, and then couple of bolts here, some on the pipes that are there, and underneath down here there are a couple more bolts on the frame on this right hand side. And coming back now on this battery, we have bolts there, and here we have bolts on the frame on the front side. And as you can see, there are a couple of there, and there is latch. There are two prominent bolts on the latch that we can see, and below on the exhaust, I think the near the engine, there are a couple bolts. So for that particular car, I've taken over 200 images. Ideally, you need thousands or even tens of thousands of images for training a model, but this is kind of a prototype and just a demo version. So 200 images should be good to split for train and test sets. And here, as you can see, the images are from not only the engine part, engine compartment, but also the rear wheel axle, but most of them are from the engine bay or the bonnet. Now the process is you first collect the images, and then I've labeled them. So I've marked in each of those images which part of that image is a bolt for the training set, and then for test set there are no labels. So the computer trains on the labeled train data. Here I've fed all the images to a neural network. I won't go into details here, but once the model is trained, we can submit a new image to that particular model, and in that model, what the model will do is identify if there are any parts of that image are bolts, and if it's a bolt, then it'll flag that and create a rectangle around it and tell that that's a bolt. So let's look at some of the results now. This is the very first picture of the engine, and as you can see here, it has correctly identified these bolts up there, and also this bolt. There is one false positive on the left hand side, but that's kind of expected. uh, Next, here as you can see, for the rear wheel assembly, it was able to identify this hexagonal nuts and bolts both. And then moving on, this is the latch assembly, and this is kind of interesting because apart from these two prominent bolts up front, there is one bolt right behind. There is a hexagonal nut that it was able to identify, and interestingly it identified this wire. This is the ending of the wire that is in a square metal shape. I thought that it's a bolt, and so it's flagged as a hexagonal bolt there. Now, along with that latch that we saw earlier, here we have two bolts that are on the front frame of that engine bay compartment, and it was able to identify those as well. And this is a bigger picture. Now in this picture, the model had to find the bolts not only on the engine but also on the front frame, as well as this additional pipes that are attached to the engine, and it was able to identify most of them. It did miss a few. It also missed the bolts at the latch, but that is still okay, because it was able to identify most of the bolts that we can see here in the picture visually. Now moving on to the battery side, we see that there are false positives on the top left corner, but then it did identify these bolts near the electrode, as well as this clamp where the battery is fit on the frame, and then there is another clamp plate that is fitted here on the right hand side. So those, it was able to detect those as bolts as well. And in this picture, this is a busy picture. Here we can see that there are bolts identified on the frame on the left hand side, then this big bolt for the I guess that's for chassis, and then there are three bolts right here, couple of bolts here, and then two bolts that are down right here. It didn't find these bolts on the pulley. I was expecting it would, but if you had more images, I'm positive that it would be able to find those bolts as well. And moving into the engine compartment, these are three prominent bolts. So if the pictures are more clear and there is less noise in the picture, then it probably becomes much easier for the model to identify that those are the bolts, as is the case in this picture. And that was it for this video. I hope you enjoyed this video about another real world application of identifying bolts in a car. And you can think of different applications of this, not only for automotive car, but you could identify bolts on bridges, on pipelines, on railway tracks, or any other machinery that may be there that has bolts on it. And you could count the bolts. You could also characterize the bolts as faulty or not faulty, if they need to be replaced, or if there are missing bolts anywhere. All of that can be automated using applications such as this one. Thank you. I hope to see you all in the next video. If you have any comments or suggestions, please let me know in the comment section below. Please like, share, and subscribe. Thank you.